Hello and welcome to this course, a practical guide to power measurements. My name is Kitesh Narandas. I am from South Africa but living in Mauritius. And at the time of this course, I am 48 years old and have 25 years of experience as an electrical engineer. I am registered as a professional engineer with the Engineering Council in South Africa since 2007. My background started in power quality and electrical equipment standards at a utility, where I was left by myself as a graduate to start the quality of supply monitoring and reporting for the utility. So my experience comes firsthand, mainly from my own methods. Then I moved into building services and infrastructure consulting, and later into a mix of the two, but doing mostly consulting. Because of my background, I am asked by various other consultants to carry out power measurements on their behalf at their project sites. I have used my experience of conducting measurements at more than 200 sites and some of my difficulties experienced and methods applied to produce this guide, which will hopefully help you in a practical environment. This course is broken up into 7 sections and videos. The slides and detailed notes are available to download, and you may want to go over the detailed notes again after watching each video. What is this course about? This course covers carrying out power measurements for the purpose of data logging of loads and other power parameters, or for quality of supply measurements using special instruments that can perform single or 3-phase measurements. Why would you need to carry out power measurements? Power measurements and data logging are required for many reasons, such as determining the existing load on a network or building for the purpose of planning or expansion, to check for power quality issues affecting electricity users or equipment, and to determine if there are faults in an electrical system. What are the procedures and safety? This course demonstrates the procedures and safety requirements for measuring power at low voltage supplies, typically less than 1000 volts, or for medium voltage supplies typically over 1000 volts, such as at 11 kV switchgear panels. Where would we carry out measurements? Low voltage measurements would normally be taken at the distribution panel circuit breakers in a building, next to a transformer room, or at the main or feeder circuit breakers in a miniature substation or in a distribution panel. What are we looking for? The measurement parameters of interest are voltage and current. They must be measured correctly to give the power, which is the kilowatts, the kVA, the kilovars, and the power factor. So here we have an example of your various power parameters. So we have a right angle triangle, and on this right angle triangle, your VAs would normally be on the hypotenuse. Your flat section here would be the watts, and then you have VAR, and you have an angle X. Now, when we look at this triangle, cos of angle X is equal to your watts over VA, which we want typically to be less than equal to 1. So less than 1 would be a lagging power factor, and 1 would be a perfect power factor. For a power factor of 1, angle X would be 0, which means your VA and your watts would be the same. Now let's explain this on a vector diagram. So here you have a vector diagram of a 3-phase system. And you have the 3 red lines are your 3 voltages, and the blue lines are your 3 currents of your 3 phases. Now in this system, let's assume we have an anti-clockwise phase rotation, and this angle between your voltage and current would be angle X. And we say we have a lagging power factor because when we look at our phase rotation, our current lags the voltage by the angle X. Now if X was angle 0, then your voltage and current would be together. Cos of 0 would be equal to 1, and you'd have a perfect power factor. So what we have here is voltage A, voltage B, voltage C, and then you have current A, current B, and current C. So that's basically an explanation of your 3-phase voltages and currents. Then you might also want to measure your average voltage regulation. So your voltage regulation basically shows, in this case, 400 volts, which is your nominal voltage. And then where does your voltage fluctuate during the day? Around 400 volts. So plus 400 volts and minus 400 volts, by what percentage is your voltage deviating? This is a 7-day profile in the example that I'm providing you. Then another profile that might be of interest is voltage unbalance. And to get a voltage unbalance, usually your instrument might be able to provide this for you from its internal software. But if you are exporting the instrument data into Excel, then you would need a formula such as this. VA to the power 4 plus VB to the power 4 plus VC to the power 4 over VA squared plus VB squared plus VC squared. And you would normally want to measure voltage unbalance for quality of supply reasons only. Then here's another profile, which is your total harmonic distortion. And you would measure this total harmonic distortion depending on your needs, depending on whether you really need to measure harmonics. So data from most loggers can be exported to Excel for manipulation or determining other parameters. Many of the more expensive loggers provide various profiles and event information from which their built-in software and bundled applications are able to provide the internal calculations. So here's an example of an Excel exported data, and you have your various measurement parameters, and within these measurement parameters you are then able to determine other parameters such as voltage unbalance, and you can insert the equations and then produce a profile from Excel. So what would we need to carry out successful power measurements? To carry out effective power measurements, one would need to have the correct equipment for the audit. There are many manufacturers out there that provide quality instruments for the purpose with varying product features depending on your needs. On the lower end of the scale are instruments that measure load only and are able to give you the voltage, current, and power parameters with lower sampling rates. The more advanced equipment would look at power quality and harmonics and higher sampling rates. Those that have event capture are also more costly because they can capture high-frequency events. Here's an example of a voltage profile with transients. So you have disturbance, you have a disturbance, which you would call a transient or a voltage spike, and it's a high-speed, high-frequency event. And in order to capture these high-speed, high-frequency events, you would need an instrument that's able to perform high-speed measurements. And these instruments become much more expensive. So equipment sampling rates make a big difference to the cost of the equipment. As someone that may be measuring power on a regular basis, you would need to decide which product features best suit your needs and budget. Now here's a typical profile of current over a 7-day period at building ABC. And then here's a profile of the power at the same building, and that gives you your watts, VAR, and your VAs during the 7-day measurement period. So if you are a building services or infrastructure consultant, it is likely that you would be looking at the loads and power only. But if you are assessing voltage quality, you may not be too concerned with load, but you would need a good voltage and frequency recorder that measures data according to a power quality standard. Here we show again the total harmonic distortion profile. And if you design power factor correction or harmonic filters, you would be interested in a very advanced instrument that does load and harmonics. And not just total harmonic distortion, but you may want individual harmonics as well. Because if you're designing power factor correction, you want to ensure that you don't have harmonic resonance on any of the harmonics, the third or fifth, and that would amplify those harmonics. So, manufacturers such as Fluke, Tranitz, Unity, Yokogawa, Majortech, Hayoki, Yanitsa, these are some of the brands you may consider. So do your homework carefully before deciding what to purchase. Decide what you're actually going to use the instrument for, because prices vary significantly. And there's no point having an instrument that's going to do high frequency, high speed recording when all you're going to be doing is load profiles and determining existing loads on feeders and building incomers, because then you'd just be wasting your money. So this was a brief introduction into what this course is all about. What have we discussed? The purpose of carrying out power measurements. The voltage measurements for power measurements. The voltage levels for power measurements. My apologies. The measurement parameters and profiles. And the types of equipment features you would likely need. In the following videos, we will cover understanding your instrument, typical measurement locations, measurement parameters and equipment configuration, on-site connections and safety, instrument configuration and download, and reporting. Thank you, and I'll see you in the next video.